For centuries, builders searched for a way to create structures that would last, not just for decades, but for generations. They turned to a principle that was as old as civilization itself, a rule of proportion. This idea, passed down quietly from master to apprentice, shaped the buildings that have stood the test of time. A 1,000-year-old roof can stand without steel, without concrete, and without a single calculation written down. That's not luck. That's a rule modern construction quietly forgot. Here's where it gets interesting. Long before engineering textbooks and digital load calculators, builders across Europe, Asia, and the Middle East relied on something deceptively simple: proportion. Not rough guessing, precise, repeatable proportion passed down through generations. And, one of the most powerful of these was the beam sizing rule. The idea was straightforward. The depth of a wooden beam should be directly related to its span. In many traditions, the rule settled around a ratio. The beam's depth should be roughly 1/10 to 1/12 of its length. So if a beam spanned 12 feet, its depth would be about 12 to 14 inches. No equations, no software, just geometry and experience refined over centuries. And it worked. Not because these builders were lucky, but because they understood something fundamental about how materials behave. Understanding the logic behind the rule. Wood bends. That's the first principle. And when it bends, the top compresses while the bottom stretches. The taller the beam, its vertical depth, the better it resists that bending. That's why depth matters far more than width. Old world builders didn't need to explain this with formulas. They saw it. They tested it. They built, watched, and adjusted over generations. A beam that sagged too much was replaced with a deeper one. A beam that held firm became the new standard. Today, building codes are filled with numbers and strict requirements. But, ancient builders relied on experience and observation. They trusted their eyes and their hands, not just rules written on paper. Sometimes the old ways hold lessons that modern codes forget. Over time, this evolved into a rule that balanced strength, efficiency, and available materials. It wasn't overbuilt, it wasn't wasteful, it was just right. And that's the part modern systems often miss. So, why did modern codes move away from the old methods? Well, today's building codes don't rely on simple ratios anymore. Instead, they use these pretty detailed calculations, based on load, material properties, safety factors, and environmental conditions. On paper, that definitely sounds better, and in many cases it really is. But there's a trade-off, of course. Modern codes are designed to cover, just about every possible scenario. Extreme weather, variable materials, unknown workmanship, all of it. That means they tend to overcompensate. More steel, more concrete, more margin. Old builders just didn't have that luxury. They built with what they had, right where they were. Their rules had to be efficient because, honestly, resources were limited. You couldn't just double the size of a beam just in case. Every single tree mattered. So, instead of overbuilding, they optimized. Here's the clever part. Their proportional rules naturally scaled. A small structure got smaller beams. A large hall got massive ones. The relationship stayed consistent, which kept structural behaviour predictable. That kind of elegance is rare today. So, let's think about this. If you're faced with a real-world challenge, like, say, building something that just has to work, these old methods really shine. They weren't just about beauty or tradition. They were about making sure things stood up, no matter the size or the stakes. That practical wisdom, it's honestly something we could use a bit more of nowadays. The survival advantage hidden in the method. Now shift this into a survival context. If you had to build a shelter from raw timber, no engineer, no handbook, this rule becomes incredibly powerful. You don't need to calculate loads in kilograms or pounds. You just measure the span and apply the ratio. It gives you a starting point that's been field-tested for centuries. And, well, it's forgiving, because the rule leans slightly conservative, especially when using dense hardwoods. It provides a buffer against mistakes. Not perfect, but reliable enough to keep a roof from collapsing over your head. That's exactly the kind of knowledge that kept structures standing in remote villages, forests and frontier settlements long before modern infrastructure existed. Where the rule still shows up today. Even though modern codes dominate, this old rule hasn't disappeared completely. You'll still find it quietly embedded in traditional carpentry, especially in restoration work and heritage construction. In timber framing communities, builders still talk about span-to-depth ratios, not because they reject engineering, but because they trust what has already proven itself over hundreds of years. In fact, when engineers analyse historic buildings that have stood for centuries, they often find that these proportional rules line up surprisingly well with modern structural principles. Different language, same physics. And that should tell you something, the limits you need to respect. Now, this isn't magic. The rule has boundaries. You know, at the heart of all this is a kind of quiet craftsmanship. Generations of builders learning from each other, shaping wood and tradition with their own hands. These rules, well, they aren't just numbers or formulas. They're the distilled wisdom of folks who paid close attention to what works and what doesn't. So even as technology moves forward, there's still real value in listening to the lessons of the past. That's how you build something meant to last, not just for yourself, but for those who come after. It works best with solid timber beams, not engineered materials like laminated veneer lumber or steel. It assumes relatively uniform loads, like a simple roof or floor, not complex dynamic forces. And you know, it depends heavily on wood quality. A straight, dense hardwood beam performs very differently from a knot-filled softwood one. Old builders knew this too. They didn't just follow the ratio blindly. They selected the right tree, cut it properly, and positioned it with care. The rule was part of a larger system of craftsmanship. If you ignore that, well, the rule loses its power. Why this knowledge still matters. In a world driven by technology, it's easy to assume older methods are outdated. But that's not always true. Some of the most resilient, resource-efficient building techniques come from times when failure wasn't an option, when every mistake had real consequences. This beam sizing rule is one of those techniques. It's simple, adaptable, and rooted in observation rather than abstraction. And in situations where modern tools aren't available, like remote builds, emergency shelters, or off-grid living, it becomes more than just history. It becomes practical knowledge, the kind that works when nothing else does. Bringing it back to the present. So the next time you see a centuries-old structure still standing, don't just admire it, study it. There's a system behind that survival, a quiet intelligence built into every beam and joint. And sometimes the smartest solutions aren't the newest ones. They're the ones that have already stood the test of time. If you found this useful, hit like, subscribe, and share it with someone who appreciates real-world knowledge that actually works. And stay with Legacy of Survival, because the past still has a lot to teach us.